Hello everyone, today I'm going to be showing you guys how to make this tile wall where you can remove random tiles, both large and small. You can keep everything, remove a piece, or keep all of the small tiles intact, or just remove a few of them along the way. So you get a bit of variations in how your tile works, as well as be able to control things like the actual removal through another shape, like with this. With this, you'll be able to create something like the tiles you might see on the sides of buildings or in the bathroom, akin to these that sell as one big tile that can fall out, as well as the individual tiles within themselves that can also end up falling out. So let's get into it. So here we are in a brand new project. And as always, we start by going to our plugins, searching for Procedural, and enabling Procedural Content Generation Framework, as well as the Geometry Script Interlope to get access to a few more options in the PCG graph. And then we restart. Once we have restarted, let's go ahead and create a PCG graph by right-clicking and searching PCG. And I'm going to call it PCG Tile Wall. And we're also going to make a blueprint, an actor blueprint. I'm going to call it BP Tile Wall. And we're going to open up the blueprint. Inside here, I'm going to add a scene component just to get rid of the icon. So the default icon disappears. And then I'm going to add a spline like so. And now to make our lives a little easier, I'm going to go delete the last point here and then right click on it and then go to spline generation panel. And I'm going to generate a square. Let's make it by default something like 200 by 200. There we go. Close out of here. Go ahead and search for closed. So you want to turn on closed loop and enable that. And then to get rid of this little curve, you just right click, spline point type linear, and then everything is closed off. So now we have a square to play with by default. Before I add the PCG graph in here, what I'm going to do is actually make a copy of this blueprint. So I'm going to duplicate this blueprint and I'm going to call it tile wall removal. And inside of the removal blueprint, we're going to go ahead and with the self-selected search for tag in the details, I'm going to give it a tag. I'm going to call this no tile. And this is the blueprint that we're going to be using to remove anything we don't want from the graph. And we can close out of here. And for the original tile wall, we can go ahead and add a PCG. And in here, we go ahead and plug in our tile wall that we made. Now, right away, I'm going to add a couple of variables in here to make it easier for ourselves. I'm going to add a large tile density, and we're going to make it a float and make it instance editable. And we're also going to get a small tile density. Same thing, float, make it exposed. And this one is going to be grid direction. And this one will be an integer. And we'll expose this as well. And you will see why we need this grid direction in a little bit. Compile and save, and then we are done here. Go ahead and bring this out. Let's get the tile wall in here. And this is going to be our little playground. So now go ahead and open your PCG graph. And in here, we're going to get the spline data. And we're going to sample the spline. So search spline for the spline sampler. And in here, if we preview it, we can see the points are on the spline itself, but we don't want that. We want to be on interior. So we select interior and immediately you see the large points in here. So the points are way too large. I'll go ahead and change the interior sample to something maybe like 30. Interior border also 30. It's better, but it's still quite large. So maybe something like 20 and 20. And you know what? Let's go and make this entire thing just a lot larger on the ground. In fact, interior border, let's make it 10 so we can actually see the points. So that way they're not touching each other. Effectively, if these numbers are the same, they're touching. So it looks like a perfect white thing. So I do like 18, you can see it starts to create that grid. So this is probably good, but it's hard to tell. So I'm going to stop sampling this. And what I'm going to do is right away, just plug in a static mesh spawner. And in here, I'm going to add my tile. And the tile I'm using is just one I got from Megascans. It's a simple clay tile. Plug this in, and we can see how big we kind of need to make this. So you can see how big these are. And you know what? For now, I will leave it as is, but I know I'm going to adjust this later. So right at the start, I'm going to get another spline data. And this is going to be, instead of the spline that we have here, we're going to say all world actors by tag, and we're going to put in the tag that we put in to the second removal spline. So this is going to get our information of how to remove these. So I'm going to go ahead and plug this in for another spline sampler. And in here, I'm going to make these the exact same, 20 by 20. So there's no gaps in between. And instead of plugging into the sampler by default, we're going to get a difference node. And the difference will be this new information. Now, currently it says warning that there's no spline in the scene. And that's fine. This is a warning. This is not an error. So now if I drag in the removal in here, you can see it, if I line it up on the points exactly where it's in the middle, it doesn't quite work on interior, but as soon as I offset it to be not in the middle of this grid, the whole thing works beautifully, and I can adjust this as needed and make a cutout of any shape I want. Okay, now that we know this is working great, I'm going to go ahead for now and remove the hole that we made, and then I'm going to regenerate it to get a full grid back, and let's continue with this. So in here, I'm going to move the static mesh spawner to the right, and I'm going to drag out and search for density, or a density noise, which will get us random values for our points. And then I'm going to get a density filter. So if I search for density filter, you see we have a lot fewer points. So if I unhook the static mesh spawner from there and hook it up to this density filter, we're now removing random points within our parameters. So our lower bound is 0.5, upper bound is 1. So if I did 0.2, it'll remove less, 0.1, remove less. So we can control how many points we want to remove. Now, we created a variable for this, so we can actually search for get actor property, and we can get our property name being our variable. So I'm going to go ahead and open our tile wall, and I'm just going to go ahead and just copy large tile density, so I make sure it's spelled exactly correct. Plug this in. And I'm going to open up our density filter. I'm going to plug this into our upper bound. Now, by default, everything disappears because the default value for this large and small is 0. So I'm going to make the default for both of these to be 1. And I'm going to give the slider range a value of 0 to 1. So that way we don't accidentally put values outside the range in here. So we can collapse this. So now we have the ability in here, if I select it, to control how many points we have left, right? So I can really quick adjust how many points. This still doesn't quite look correct. So let us continue. So we want to make the tile be made up of multiple tiles, like the original reference. So for that, we're going to get a create points grid. Now, if I sample this, nothing shows up anywhere. And by default, it wants to be inside of a volume. In the options here, in the details, with it selected, you want to turn off cull points outside volume. You want to uncheck that. And immediately you could see these points have appeared. So here are the points, and if you turn this on, right, it disappears. Because it's expecting a volume, but we are in a spline, so that's why you don't get anything. Let's tweak these values. So grid extents, let's make it something like 20 by 20 by 20, with the cell size being 5 by 5 by 5. Let's play with this as a size. That might be a little too small given the size of these. So let's actually increase this to maybe 10 by 10 by 10. And that looks about right for this tile. We'll adjust this, of course, as needed. But let's make it, each one, let's say, is going to be 50 by 50 by 50. That seems pretty good. So now we want to get these points in here. So for that, we're going to go ahead and copy points. The source is going to be our original points, and the grid is going to be the target. So if I unhook this and plug this in, we now have a lot of overlapping points here. So we got to adjust some values. So in here, instead of 20, 100. If I go 105, you can see there's a gap. 102, still a gap. And you might want a gap in between them, a little bit of extra. So in fact, let's go like 100.5. So we get a little gap in between them, or maybe 101. So we have a little bit of a gap in between the large tiles, so we can really tell them apart. And we want to also, we can start sampling this, adjust the value here. So we have a little bit too much of a gap in between these. So let's do something like 9.2 seems good. And if it's 9.2, then we can go ahead and lower this again. We can lower this to 93. So now we have a grid of grids, effectively. And if I come into the blueprint and I remove half of them, you can see it is removing the full grid of tiles. It is not removing one by one. So we want to be able to do both. Do the full grid as well as individuals. First things first, what I'm going to do is add a self-pruning node. And the reason I'm adding this self-pruning is because technically the original point that we used to place this grid on is also part of the grid. So we have this point overlapping. So in that one instance, there would be two tiles on top of each other. So the way to fix that, you introduce the self-pruning and you change from large to small. Instead, you want to do remove duplicates. So if there's any point that is exactly on top of each other, it will just go ahead and remove it and keep only one copy. So visually, you're not going to see any difference right now, but trust me, it has removed one duplicate of the tile in each section. So at which point we want to be able to actually remove individual points, the small tiles as well. So let's go ahead and do the same thing we did before. In fact, I'm going to go ahead and just duplicate this density noise and density filter. I'm going to plug in the self-pruning and swap out this density filter in here. And for density noise, I'm going to give it a different seed. And for get active property, instead of large tile density, we had small tile density. So now, if I go and select this, and in our blueprint, I can remove a few random tiles that are large, and I can start removing small tiles. Of course, they're not exclusive. You can remove randomly the small tiles and randomly the big tiles. You get some really interesting effects here. Now, let's take this a little step further, because currently they're all perfectly the same. So let's go ahead and just add a transform points here, plug this in, and we're going to give it a slight rotation. I'm going to say -2 in all axes to 2. Give it a little bit of that wobble, make it a little bit more realistic. So now if I come down here, you can see they're all just a little bit offset, and that really sells it. So if I increase the amount we had, you could see it's just a little bit of extra realism there for these tiles. Now, we're almost done with this, but you might notice a problem when you go and take this and rotate it. And that is now, because we've copied this grid, it works with the floor, but it doesn't work for the wall. And we can fix this pretty easily with last variable we created, but we didn't use yet. And that's for this create points grid. So we're going to get another active property. And again, we're going to copy the variable name, this grid direction, and we're going to plug this into our property name. And in the create points grid, what we're going to do is coordinate plane axes. Plug this in here. And now if I change the grid direction to 1 and then 2, you can see it is now rotating it. Just like that, we have in the correct way. But of course, if I rotate it 9 degrees, then we have the same issue. And then we just put it at 1, and now it's correct for this. So this is adjusting that grid rotation based on how you want it. So effectively now we can have 4 walls of a room, probably of a bathroom, randomly missing tiles, both large and small. But just like that, we have this tile wall with missing pieces, both large and small. And of course, you can play around with these shapes in any way you want. By just holding down Alt, you can create new points and make this as any shape you want. And of course, now, just like we can drag out this tile anywhere we want and control all the values of how many we want to keep, we can also drag in the tile removal and just remove points any way we want. Now, if you want to be able to remove individual points, not just the full tile itself, all you need to do is move this section over here past where you add this grid. But in my case, because the idea is I would want to remove the full tiles and not the individuals, it is at the beginning. And then you'll be able to remove individual points and not the full tile itself. Hope you guys enjoyed it. If you liked it, hit the like button, subscribe if you haven't, and I'll see you guys next time. Take care. Bye.